Okay, so maybe let us see this proof. How do we handle this proof? And please don't forget to subscribe to the channel. Now, how do this proof? So that they are giving us y as sine a, sine plus sine a, and then so x is equal to tan a minus sine a. They want us to show that it's equal to that. Now we see that they are eliminating tan and sine, so you should focus on that. You can pause the video and try the equation out, then you come back to the question. Anyway, to handle that, now the hint we are going to use here is, you know that cot A is the same as the reciprocal of tan, and cosec is the reciprocal of sine, and then this third identity, that cot squared plus 1 is equal to cosec squared, and we're also going to use the idea of a difference of two squares. So if I call this one equation 1 and I call this equation 2, I want to eliminate the 2. So if I say 1 plus equation 2, if I add this, I have 1 plus x equaling 2. If I add this one, so I have 2 tan a. This one will disappear, so to make tan a the sum is there. But from there, my tan a is going to be y plus x over 2. Now, what if I say subtract the 2? If I say get equation 1 minus equation 2, so I'll be adding y minus x equaling 2. This minus this will go, then this minus minus will give me 2 sine a. From there, you see that my sine a over 2. So you see that now these ones, all of them, sine, tan, and sine, there's not any trig identity that is relating them, but there's a trig identity that is relating the reciprocal of these two. So from here, I start my cot A will be 2 over y plus x. The reciprocal of tan gives you a cot using this idea. And also from here, if I get a reciprocal, I get cosec A will be 2 over 1 minus x. So from this formula, which says that now cot squared A plus 1 equaling 2 squared A, I substitute the 2. So I'm going to be adding this here as 2 then plus 1 equaling cosec, which is 2, the whole of this squared, y minus x, the whole squared. Squared in those two, when I square this, I get 4. This will be then plus 1 equaling 2. When I square this, I get 4. The whole squared. So that the LCM is this times this, so multiply through by this LCM. When I multiply it here, the LCM, so that our LCM from there is going to be y plus x, the whole squared, into y minus x, the whole squared. So if I multiply through by the LCM, here I'll be adding 4 into, when I multiply this here, I'll be adding now y minus x squared surviving, then plus this multiplied here, we have equaling 2, then multiply it there, I have y plus x, the whole square. If I multiply it here, then there is that we are going to, when I bring this side, when I take everything the other side here, it's that I have a square common, so I have y, but the square is common, equaling 2, we have 4 into, you can easily expand that as plus 2xy, then plus x squared, then minus, when I bring this side, 4 into y squared minus 2xy plus x squared. So this is the difference of the squares using this idea. So it's like this will be now y squared minus x squared, the whole squared equaling 2. 4 into, when I open the brackets, okay, I'm going to be adding 4y squared plus, this will give me, this time I'm going to be adding 8xy plus 4x squared. So it's that they are going to cancel, so y squared minus x squared, the whole squared will be this 8 plus this 8 gives me 16xy, and that be the proof, because these ones are going to vanish. So don't forget to subscribe to the channel. I wish you the best. You can send in the proofs you want me to handle.